Good day, I'm Fernando Manalo from EC42, and today's experiment is for TECT413LA, which is the Data Communications Laboratory. And for today's experiment number 4, we will be doing an experiment in two parts, which is to install the Wireshark and to use the Wireshark to view network traffic. I will start the experiment for 4A, install Wireshark. The objective of this experiment is to download and install Wireshark. The background. Wireshark is a software protocol analyzer or packet sniffer application used for network troubleshooting, analysis, software, protocol development, and education. And the required for this is one PC, Windows with internet access. The instruction is Wireshark has become the industry standard packet sniffer program used by network engineers. This open source software is available for many different operating systems including Windows, Mac, Linux. In this lab, you will be downloading and install the Wireshark software on your PC. Wireshark can be downloaded from wireshark.org. We'll go to Wireshark.org. Choose the software version you need based on your PC's architecture operating system. For instance, if you have a 64 Windows, download, we'll go download Windows 64-bit installer. The downloaded file is named Wireshark. X represents the version number if you download the 64-bit version. Double-click the file to start the installation process. Respond to any security messages that may display on your screen. If you already have a copy of Wireshark in your PC, you will be prompted to uninstall the old version before installing the new version. It is recommended to remove the old version of Wireshark prior to installing another version. Click Yes to uninstall this version. If this is your first time to install Wireshark, or after you have completed the uninstall process, you will navigate to Wireshark's Setup Wizard, and then we will click Next. Continue advancing through the installation. So basically, we will install the Wireshark. It's already finished downloading, so open the file. And here is the Wireshark Wizard. Next, so to the EULA, user license agreement. Should be fine. This is a recognized software. And then you can change the integration. Yeah. Next, start menu icon, launch menu. Okay. And to capture live network data, npcap must be installed on your PC. If npcap is already installed on your PC, the install checkbox will be unchecked. If your installed version of npcap is older than the version that comes with Wireshark, it is recommended that you allow the newer version to be installed by clicking the Install npcap XXX version number, and then click Next to continue. Do not install USB cap for normal traffic use. Do not select the checkbox to install USB cap. Wireshark start installing its file displays the status of installation. In a separate window, accept the license agreement in the npcap. Next, do not It said do not install USB cap, so will not install USB cap. Now we're at installing its files, and we will wait. And now here is the end user license agreement. We said click I agree to continue. Click install to install and pick up. Install and pick up. Wireshark, in a separate window, accept the license agreement. If installing and pick out, click I agree. Support 11 traffic. Install. I will click next when the Wireshark installation is complete. And then click finish to complete the Wireshark install process. And as you can see, we're currently at version 3.3.4.9 64-bit. And the Wireshark is successfully installed. Then we'll finish the setup wizard. And that is the end for the part 1 of this experiment. For the next part of this experiment, we are to use the downloaded Wireshark to view network traffic. The objectives of this experiment is to capture and analyze local ICMP data in Wireshark and capture and analyze remote ICMP data in Wireshark. The required resources are one PC and additional PC, but in this case, I will be using my Raspberry Pi as I don't have any other PC. It should be fine. For in part 1 of this lab, we will ping another PC on LAN and capture ICMP requests and replace in Wireshark. This analysis should help clarify how packet headers are used to transport data to their destination. For this lab, you will need to retrieve your PC IP addresses and its network interface and IC physical address, also called MAC address. In the command prompt, enter ipconfig all so that we can know our IP and the MAC address. So Windows R and ipconfig config/root, and here are the details of my device, and we will go to the wireless LAN adapter Wi-Fi as I am on Wi-Fi, and here is my IP address 192.168.2.55, and I also need the MAC address, which is this one, the physical address. And for the Raspberry Pi, I will open this keyboard so that we can access the terminal. And here is my Raspberry Pi, and in this case, I will be using ifconfig -8, and I'm also on Wi-Fi, and in this case the IP address is 192.168.2.194 and the MAC address is this one. For the next step, start Wireshark and begin capturing data. We'll open Wireshark. Then we have to select which one has traffic. Make sure the desired interface has traffic. And since I have on Wi-Fi, this one has traffic. Information will start scrolling down. The data lines will appear in color space of protocol. In this lab, we are only interested in the ICMP ping PDUs. And to do this, we will type ICMP in the filter box at the top of Wireshark. So ICMP. And as you can see, the other packets are not visible anymore. And then the next step, this filter causes all data to disappear, but you're still capturing data traffic on the interface. Navigate to command prompt and ping the IP address that you receive from your team member. In this case, I will ping the IP address of my Raspberry Pi, which is ping 192.168. It's this one. 192.168.2.194. 192.168.2.194. And we have successfully pinged the Raspberry Pi. Now we will go back to Wireshark, and as you can see, there are now some data that we can see. And then we can skip this as I've already received the, and then we can stop capturing data. In step 3, examine the data that was generated by the ping request of your team member PC. Wireshark data is displayed in 3 sections. The top section displays the PDO frames, which is this one, with a summary of the IP packet information listed. And then the middle section lists the PDU information for the frame selected. These ones are the frames in the top part of the screen and separates a captured PDU frame by its protocol layers. The bottom section displays the raw data of each layer. The raw data is displayed in both hexadecimal and decimal form. Click the first ICMP request PDU frames to the top and notice the source column has your PC IP address, and this is my IP address 192.168.2.55, and the destination column is the IP of my Raspberry Pi. With the PDU frame still selected, navigate to the middle section. Click the plus sign to the left of the Ethernet 2. With this, the PDU frame still selected. Does the source MAC address match your PC interface source? And to verify that, you have to go back here, and my physical address is 70.6655B1AFB1. Yes, and yes, it matches. As a destination MAC address, Wireshark match your team member to see that. You'll go to BNC, and the MAC address is E45, destination E45F 014B3389. How is the MAC address of the ping PC obtained by your PC? In this case, the MAC address is obtained using ARP or Address Resolution Protocol. In part 2, capture and analyze remote ICMP data in Wireshark. Start data capture again. Continue without saving. With the capture active, I will ping these 3 websites. for Google. When you ping the URL selected, notice the domain name server translate the URL to an IP address. And we can see that here. When we ping google.com, it pings the IP address of google.com. In this case, Cisco, here is the IP address of Cisco, and for Yahoo, here is the IP address of yahoo.com. Now we can stop capturing data by clicking the stop capture icon. Examining and analyzing the data from the remote host. Review the captured data in Wireshark and examine. Before we do that, let's enable editing and answer this word. The IP address for yahoo.com is 180.222.102.201. Should be in the lower, this one, 180.222.1. Just like 180.222.102.201. The MAC address we can see here at the Ethernet. Source destination F0 F0 9F C2 1649 for C. For Cisco.com, it is 123.8, which is this one. This one is Cisco.com. So the IP address is 23.8.211.237. MAC address, as you can see, the MAC address is the same, 4946, so you can just copy this. For google.com, should be here the last part, which is this one, the 142.250.204.100. And as you can see, the MAC address is still the same. What is significant about this information is that the MAC addresses for all are the same. MAC addresses are the same. How does this information differ from the, in the first part, we ping the local area, device connected in local area, and it returned the physical address or the MAC address of the PC, NIC, or NIC. However, for the remote host, it returned the physical address of the default gateway, local area network gateway. That is the physical address of the router. And why does Wireshark excuse me. Uh, for the reflection question, why does Wireshark show the actual MAC addresses of the local host but not the actual MAC address for the remote host? Uh, we'll skip the appendix as we didn't need that word in this case. Uh, the Wireshark shows the actual MAC address of the local host because the MAC addresses are known in the local network. However, but when the ICMP is for the remote host, the the MAC addresses of this remote host are not known by the network. So after the packet reaches the default gateway router, the layer 2 information, which is this one, is stripped from the packet and the new layer 2 header is attached with the destination MAC address of the next hop user. And that explains why we cannot know the physical address or the MAC address of the remote host, but we can know the MAC address of the local host. And that is the end of today's experiment. Now we have successfully used the Wireshark to view network traffic, but only the ICMP, but in both the local hosts and the remote host, as we have demonstrated in this experiment. And we have successfully achieved our objective, which is to capture and analyze the local and remote ICMP data in Wireshark. And that's the end of today's experiment, and thank you for watching.